Let's see example 2.3. Example 2.13. Example 2.13. F modulus z is equal to 2, show that modulus z is equal to 2, show that 3 less than or equal to modulus z plus 3 plus 4i, which is less than or equal to 7. What is it? F modulus z equal to 2, show that 3 less than or equal to modulus z plus 3 plus 4i, which is less than or equal to 7. Solution. What is given, ma'am? Given modulus z value which is equal to 2. To show that is to prove 3 which is less than or equal to modulus z plus 3 plus 4i, which is less than or equal to 7. Which is less than or equal to 7. Now, given proof can be splitted into modulus z plus 3 plus 4i. It can be written as modulus z plus 3 plus 4i, which can be written as, to prove first this inequality and then this inequality. So first inequality, consider modulus z plus 3 plus 4i, which is less than or equal to 3. So take it less than or equal to modulus z plus 3 plus 4i, which is less than or equal to prove it, what? 7. So which is less than or equal to, write it separate modulus. Modulus z plus modulus 3 plus 4i. Modulus 3 plus 4i. Why here we write it as separate modulus? Because we know the property modulus z1 plus z2, which is equal to modulus z1 plus modulus z2, which is, this inequality is here equal to modulus z value is 2, given 2, plus modulus 3 plus 4i value, taking square root, 3 square, that is 9, plus 4 square, that is 16. So 2 plus 9 square root of 9 plus 16 values, square root of 25. Square root of 25. 2 plus square root of 25 values, 5. So 2 plus 5 is 7. What is left hand side? Here left hand side is modulus z plus 3 plus 4i. Here we follow these steps, so write it equal. Write it equal. But when we write it a left hand side, that time compulsory used a less than or equal to symbol. Now, what is LHS, ma'am? LHS is modulus z plus 3 plus 4i, which is less than or equal to 7. Just less than or equal to 7. Take it equation number 1. Take it equation number. Next, consider inequality modulus z plus 3 plus 4i greater than or equal to, just greater than or equal to inequality. So now splitted here using a greater than. So greater than means splitted into minus. So modulus z minus modulus 3 plus 4i. Modulus 3 plus 4i. Next, which is equal to modulus z value is 2. Modulus z value is 2 minus square root of 3 squared is 9 plus 4 squared is 16, which is equal to 2 minus square root of 25, which is equal to 2 minus square root of 25 values 5, which is equal to minus 3, which is equal to minus 3. Okay, here we got minus value, but we prove that only the positive value. We prove that only the positive value. In that situation, simply here we write it as, here write it in separate modulus, am I right? So taking whole modulus of this term, taking whole modulus of this term. So now taking whole modulus of this term, we got it positive. Modulus of minus 3 is also plus 3. Okay, now the proof is over. Write the left hand side. Modulus z plus 3 plus 4i, which is greater than or equal to 3. Which is greater than or equal to 3. Once again, less than detract consider the next inequality. Next inequality is what? 3 less than or equal to modulus z plus 3 plus 4i, or modulus z plus 3 plus 4i, which is greater than or equal to 3. We said any one. Okay. Now, modulus z plus 3 plus 4i is considered. Okay. To prove that which is greater than or equal to 3. Which is greater than or equal to 3. So, which is greater than or equal to, greater than means use it a minus, split it into minus. So, modulus z minus modulus 3 plus 4i, because we know one property modulus z1 minus z2, which is greater than or equal to modulus z1 minus modulus z2. Okay, which is equal to modulus z value is 2 minus square root of 3 square 9, 4 square 16, taking whole modulus of this, because we got some negative value. So that purpose only, to remove this, that purpose only we taking whole modulus here. So modulus 2 minus root 25. 2 minus 5. 2 minus 5 value is minus 3. So modulus of minus 3 is plus 3. So consider this equation as true. From equation 1 and 2, from equation 1 and 2, we get, what do we get it? 3, which is less than or equal to modulus z plus 3 plus 4i, which is less than or equal to 7. Which is less than or equal to 7. Am I right? So hence the proof is over. So we said hence it is proved. Hence it is proved. Hence it is proved.